Hello, my name is Benjamin Branstetter, and today I'll be going over Physics 2211, Lab number 3. So, what are some key concepts we use in this lab? Well, we use Newton's first law: an object in motion tends to stay in motion unless acted upon by an outside force. Newton's second law: the force on an object is equal to the object's mass times its acceleration. And we made some assumptions, no major ones, aside from the ship being a point mass and the only forces being present in the second experiment being those given by the planets. So what are some important formulas we used? Well, we used the position update formula, RF equals RI plus V delta T. There's an example of it in the code. We used it multiple times like the rest of these formulas. They just looked a little bit different depending on what we were trying to calculate. Really just the variables were changing, nothing else within the formula. So we also used the velocity update formula, VF equals VI plus F net over M delta T. And we used the force update formula, GM1 M2 over R squared. We used this to calculate the force, and then we added the forces together to find the F net. So what was the purpose of this lab? Well, we had two parts. The first part's purpose was to see if we could calculate the mass of a black hole using the force update formulas. And then the second part, we wanted to see if we could create a computational model simulating the flight of a rocket around a moon and a planet. If we correctly completed the first part of the experiment, we should see that the star orbits the black hole one time and its corresponding force and change in momentum vectors are always pointing towards the black hole or in the direction of movement. If we correctly completed the second part, the ship should survive for 700 hours. So here's my free body diagram. The system of the first experiment is simply the star and the black hole, and the surroundings is everything else in the universe. The surroundings in the second experiment is also everything in the universe, but the system in the second experiment is the ship, the moon, and the planet. The initial conditions of the first case is just the mass of the star being 2.0 times 10 to the 30th kilograms. The initial conditions of the second case were the planet being 8 times 10 to the 27th kilograms, the moon's mass being 6 times 10 to the 25th kilograms, and the ship's mass being 7 times 10 to the 12th kilograms. So experiment 1, what were the materials? Well, just go through software. In this particular experiment, we used the force update, momentum update, and velocity update formulas to eventually calculate the mass of a black hole. We simply had to plug each one into the other. Pretty procedural down the whole thing. This is the second experiment. Again, the materials are just GlowScript. And this one, we primarily used the force equation I mentioned earlier, GM1 M2 over R squared, and it's each specific situation to find the force, depending on what we were trying to find the force of. And then we added those forces to find F net, and we used the position and velocity update formulas to simulate the motion of a ship. So here's the code running. There's the first one. It takes a little bit of time because of the rate at which these run. We go, and this is the second one. The second one is a little bit slower because obviously it had to go for 700 hours or 700 simulated hours. But we do eventually see that the ship survives. Should be on the next pass. There we go. But what were the results? Well, in experiment 1, the mass of the black hole was around 6.81 times 10 to the 33rd kilograms, which I found by taking the average of the highest and lowest weights. And experiment 2, the speeds that I got for the ship to fly around for 700 hours straight were 2.5 times 10 to the 4th meters per second in the x and y direction both. So what are some possible sources of error? Well, it's very unlikely that mathematical sources of error occurred because it is code. Nonetheless, there could have been errors in the code itself. There could have also been a possibility of some of the formulas I used being incorrect, although that is also highly unlikely. The what if question. Well, if we were to consider the entire system, we would need to include the forces of the star and black hole in the code of the second experiment. The black hole in this case would be by far the most dominant force because its mass is several magnitudes or several orders of magnitude larger than anything else in the system. The what does it mean question. The difference between the rate of change of momentum and the net forces perpendicular and parallel components is that the force components show applied cause, while the change of momentum shows the effect of this cause. So while the force is what's causing the change in momentum, the momentum shows the force overall. So that's the experiments overall. Pretty interesting that we saw, but I could not get the ellipse or figure 8 orbit with the ship. Thank you.